In this section, we're going to take a look at our last ways of evaluating trigonometric functions. So we've seen the unit circle definition, we've seen the right triangle definition. And so this time what we're going to do is we're going to use a basic circle definition. And so we're going to have this relationship r squared equals x squared plus y squared. And then we're going to use these things called reference angles to be able to evaluate trigonometric functions. So really quickly, just to kind of derive what we're doing here. Now, recall from our triangular definition that, so for instance, if we have a triangle that looks like something like this, a right triangle, we would have some sort of coordinate, okay, that falls on here, okay? We have our circular definition, or we have the opposite over hypotenuse, etc., okay? So let's say we have a circle of radius r, okay? So, and let's say for some reason that this is our radius r, and right here is going to be the point x comma y, okay? Now we know that the height of this triangle that's going to be inscribed here inside this triangle, and let me draw that, or inside this circle, would be something of this nature right here. And we certainly know that the height of this is y, and x is going to be what our length of this triangle is going to be. And you probably remember that we had the relationship on the unit circle, but we could also go through and use our trigonometric definitions, okay? So for instance, remember if this was theta right here inside of this, right? Remember that, for instance, the tan of theta was equal to the opposite over the hypotenuse, or y over x. And so, or we had the idea that the sine function was the opposite over the hypotenuse. Now, in this case, the hypotenuse is r, and the opposite is y. And so that's where these definitions are coming in for a circle of radius r. Okay, so we're just building it right from the Pythagorean theorem, and then also with respect to our right triangular definitions. If we know that point xy that falls on the units or on this circle, then what we could do is we could use both this relationship, x squared plus y squared equals r squared, and also these definitions right here to be able to find the values of the 6 trigonometric functions. All right, so let's say, for instance, we have this point 1 comma negative 4, and I want to try to find all 6 of the trig functions. First thing we're going to do is we're going to find r by using this relationship, r squared equals x squared plus y squared. And so we would get that r squared is equal to 1 squared plus negative 4 squared. Or, in other words, r squared would be equal to 17. Now, technically, r would be equal to plus or minus 17. All right, but since we're talking about the radius of a circle, we're going to eliminate the negative. And so r is going to be the square root of 17. All right, so r root 17, x is 1, y is negative 4. And now we're just going to use these definitions, okay? And of course, we can just use the reciprocal definitions to find secant, cosecant, cotangent. So for the sine of our theta, that's going to be equal to y over r. Now remember, y is negative 4 over the square root of 17. And of course, we want to try to rationalize that. We've seen rationalization many times. So we just multiply by root 17 over root 17. And so we would end up with 4 roots, or negative 4 root 17 divided by 17. Okay, so that's our sine. For our cosine, well, that would be the x over the r. So that's 1 over root 17. And 1 over root 17, if we were to rationalize it, okay, just by multiplying by root 17 over root 17. So we just multiply it to root 17 over root 17. That's going to be equal to root 17 over 17. Okay, so that's going to be equal to the square root of 17 over 17. And then finally, for the tangent, well, that's probably one of the easier ones because that's going to be y over x. So the tangent of theta is going to be equal to y over x, which is negative 4 over 1, which is negative 4. Right. For the remaining functions, we just take the reciprocals. Okay, so For the cosecant of theta, well, that's the reciprocal of the sine. So that's going to be negative root 17 over 4. For the secant function, that's going to be the reciprocal of the cosine function, or that's the reciprocal of 1 over root 17 over 1, otherwise known as root 17. Finally, the reciprocal of tangent is going to be the cotangent function, and the cotangent of theta is going to be 1 over negative 4, or negative 1, 4. Okay, so that's how easy it is to use these circular definitions. Okay, it's actually really similar to things that we've already seen. A secondary example, we have x is equal to 2, y is equal to 3, and so r squared would be negative 2 squared plus negative 3 squared. R squared is going to be equal to 4 plus 9, which is 13. And then we would just take the square root of both sides. And so r is going to be the square root of 13. Now, technically, it's plus or minus root 13. But remember, r is always greater than 0. So r is going to be the square root of 13. Okay, and the reason r is greater than 0 is because it's going to be a radius. So remember that the sine of theta is going to be y over r. We know that y is negative 3, and we know that r is root 13, right? And I'm going to rationalize everything in a moment. The cos of theta is going to be x over r, so that's going to be negative 2 over root 13. And then finally, we have the tangent of theta, which is going to be equal to y over x. That's negative 3 over negative 2, which is 3 over 2. Okay, positive 3 times. Right. Now, if we rationalize this, then all we're going to do is just multiply anything that needs to be rationalized by root 13 over root 13. Okay, and so that should be pretty easy because we're getting to be experts at this. We've done this many times. So this will be negative 3 roots of 13 over 13 for the sine function. This will be negative 2 roots of 13 over 13. And then this one's already done, doesn't need to be rationalized. At this point, we just take the reciprocals of the original functions, okay? And so for the cosecant of theta, that's the reciprocal of sine, which is going to be negative root 13 over 3. Okay, so that's easy. The secant function is going to be the reciprocal of the cosine. That's going to be negative root 13 over 2. And then finally, for the cotangent function, that's going to be the reciprocal of tangent, which is 2 over 3. All right, so that's how we can use these circular definitions to be able to find the trigonometric functions of any angle. All right, in our next video, what we're going to do is we're going to start taking a look at the signs, S-I-G-N-S, of our trigonometric functions.